This goes. So I'm Mark Goddard. I'm on the Ironic core team, and today I'm going to talk about Ironic Deploy Templates Bespoke bare metal. So I work for a company called Stack HPC in Bristol. Been working on OpenStack with HPC since 2014, previously at Cray. I'm core in Ironic, KOB Collar, and PTL for the Collar project for this cycle. Started the KOB project and would describe myself as a YAML wrangler. Just a little about my company. Stack HPC is a software consultancy with a focus on OpenStack for scientific computing. The website's there. Check it out if you're interested. Enough of that. So I'll be talking about how BIOS and RAID is supported in Ironic today. Some of the goals for this feature. I'll do a demo in 2 halves. Cover scheduling for Ironic in Nova, the Ironic deployment steps feature, the Ironic deployment templates feature, finish the demo, and then look at how we're going to implement RAID using this feature. And finally, some of the challenges we have to continue to improve this. So the current state of BIOS and RAID in Ironic is implemented through something called cleaning. And cleaning is typically used to sanitize the hardware after it's been deployed. It's a mature feature. It's been around for quite a long time now. And the typical use case is to shred the disks, to remove any sensitive data from disks after they've been used. And it does this by executing a prioritized list of clean steps. There are 2 ways that cleaning gets used. One is automatic. So this happens automatically when a node is deprovisioned. It goes through a cleaning phase. You can also manually trigger cleaning on demand. There's a fantastic state diagram if you follow this link. I've tried to simplify it here. Essentially, nodes start in an available state. You then deploy them. They enter an ephemeral deploying state before they become active. And then when you undeploy a node, you deprovision it, it will typically go through a cleaning step before returning to the available pool. And the manual clean is represented by going from available straight to cleaning and then back to available again. Each clean step has an interface, which is a piece of Ironic, an Ironic abstraction. There are interfaces for deploying, for managing the power, the management, BIOS, and RAID. Those are the ones that are supported by clean steps. Each step has a step, which is the name of the function that you want to run, a set of arguments that you want to pass to the function, and the priority for automatic steps, the priority in which they should be executed. So onto BIOS. This feature was added in Rocky. There are 2 clean steps currently implemented. One is to apply BIOS settings. So you provide a list of names and values of BIOS settings, and the clean step will apply those. There's also a factory reset, which returns the BIOS settings to their factory defaults. And on the right, we have an example of a JSON formatted clean step for disabling hyperthreading. RAID was actually added in Mitaka cycle, so it's been around for quite a while. There are 2 steps. There's one to create RAID configuration and another to delete it. And there's a separate API that gets used to actually set the target configuration that you want to apply. So we set the target configuration and then use a clean step to actually apply it. So here's an example on the right of how that clean step looks. So this one is for creating RAID configuration, and as you can see in the arguments, we don't include the RAID configuration itself. We just say which volumes we want to apply. There are some limitations to cleaning. You can't configure the BIOS or the RAID as part of your deployment procedure. So if you want to have a pool of nodes that are configured in a specific way, it's good for setting that up. But if you want to customize a node during deployment for a specific use case, then it doesn't work for that. Cleaning, at least manual cleaning, is not available to users of Nova, so there's no way to get through the Nova API to trigger a cleaning operation. And having the RAID configuration applied in a separate API call is a bit fiddly. So to make this more dynamic, here are some of our goals. We want to allow a pool of hardware to be applied to various tasks. And we want to use an optimal hardware configuration for each of those tasks. So perhaps we have one user that wants to configure a compute node as a Hadoop node with a bunch of disks configured as a JBOD. Perhaps someone else wants to set one up as a database server with a RAID 10. Perhaps someone else wants to use a compute node for HPC, and they want to tune the BIOS for that purpose. We'd like to be able to use the same pool of hardware to do each of these different things. Some of the things that we want to deploy, to configure at deploy time, include BIOS, RAID, as we've already heard. So perhaps we want to enable hyperthreading when deploying a node. Perhaps we want to configure either hardware or software RAID on a node. Some hardware has support for something called a performance profile, so we can apply a named profile that includes various different options, BIOS options, and things like that. Perhaps a profile that's tuned for HPC. These are the common ones, but anything really that you might want to do to the hardware prior to deployment could be done through this, or we would like to be able to do it through this mechanism. We'd like to make it cloudy. So we want something that works for non-admin users. A user of the Nova API that creates an instance should be able to use this. We want something that's abstracted from the specifics of the hardware that's being deployed. And we want something that the operator can have full control of to say what can be configured and who can configure it. And we want to use the existing interfaces where possible and build upon existing abstractions. So it's a good job I have my own laptop, because now it's time for the demo. I guess you'll probably want a bit of zoom here. For those at the back, is that enough? Seeing some nods and thumbs, good. Okay, so let's see what instances we have. So this is one I made earlier. This is a compute instance with, I've realized I've skipped a slide, so I'm going to go back to my slides. So just to explain the context of the demo, we have the OpenStack controller, 2 nodes. One is an OpenStack controller. It's an all-in-one environment, and it's running OpenStack Ironic. We've got a flat network, which connects the controller to a bare metal compute node. The compute node's got a RAID controller attached to 4 SSDs. The control plane is using a pre-release of OpenStack Sign, which includes the support for deploy templates, deployed via KOB, and we have some patches applied which aren't in the Stein release for doing RAID configuration with Dell hardware. They're both Dell R60s, and the compute node has 4 SSDs, which are 372 gigabytes each. Okay, back to the demo. So we have this single instance, which is called RAID 1 times 2, because we have 2 RAID 1 configured logical disks. We've used the flavor RAID 1 times 2. And let's have a look at what's going on. So as we can see, we've got two disks, SDA and SDB, and each is 372 gigabytes. So hopefully you'll agree that corresponds potentially to two RAID 1 configured volumes. So I'm going to delete that instance now. Let's have a look at the flavors we've got. So if you recall, the previous instance was created using RAID 1 times 2. We also have a second flavor called RAID 10. Now, RAID 10 configures those 4 disks as a RAID 10 single logical disk. So here's a command I made earlier. So we're going to create a new instance called RAID 10 using the RAID 10 flavor. Now anyone that's worked with bare metal before will know that this takes a while, and we're not going to sit and watch it. So we'll go back to my slides. So all of this depends to some degree on how Nova scheduling works, particularly with the new placement service, newish placement service. And it's a little different with Ironic than it is for virtual machines. So we'll cover the specifics of how that works. Placement is a relatively new OpenStack service added in the Newton release, and in the Stein release it was extracted from the Nova project to become a separate project. It's essentially an API for tracking resources, tracking the inventory of objects and the resources they have and the consumption of those resources. It can also do scheduling based on qualitative and quantitative resources. So for any placement folks in the room, if this isn't perfect, please shout at me later. But I'll try and cover the core concepts of placement. So a resource provider provides an inventory of resources of different resource classes. The terminology will become more familiar. One of those resource providers may be tagged with one or more traits, and a consumer may have an allocation that consumes some of a resource provider's inventory. So let's try and make that a bit more concrete. For VMs in particular, a resource provider, in this case a compute node, provides an inventory of vCPU, disk, and memory resources. Our compute node resource provider may be tagged with one or more traits, and an instance, a consumer, may have an allocation that consumes some of a compute node's inventory. More JSON for you. I know everyone loves to read JSON, so here is an inventory for a compute node resource provider. So again, this is the VM case. So we've got the top level inventories key, which has an inventory for disk, memory, and vCPUs. And within each of those, we've got allocation ratios, the maximum number of units, the minimum number of units, how many of those are reserved, and the step size. And each resource provider has a generation that gets incremented with every change. So this works great for VMs, which are based on hypervisors that can be carved up. This doesn't work for Ironic. Bare metal nodes are indivisible. You can't have half of a bare metal node assigned to an instance. And you also can't overcommit a bare metal node. You've either got one bare metal node or not. So we modify this slightly for Ironic. So our resource provider in this case is a bare metal node, and the node provides an inventory of exactly 1 unit of a custom resource. The bare metal node can be tagged with 1 or more traits, and an instance consumer may have an allocation that consumes all of a bare metal node's inventory. There's only 1 of them, so you either have it or you don't. And our JSON blob in this case, for Ironic, is an inventory with a single resource class. And in this example, we're using custom gold. That seems to be people's favorite example. I don't know who's buying gold servers, but lucky them. And we can see that we've got a single unit of that resource class. So how does this map to flavors? We've got the output of this command here. We're showing a flavor called bare metal gold in JSON format. And it's a server, so it has got vCPUs, RAM, and disk, and we can represent that within the flavor. But in our properties, in extra specs, as they're sometimes called, we set those resources to 0. So the disk GB, the memory MB, and the vCPU are all set to 0, so we're not actually requesting any of those resource classes. What we are requesting is 1 unit of the custom gold resource class. So traits are how we model qualitative aspects in placement, and a resource provider can have 1 or more, or 0 or more traits. And in this case, the example shows a resource provider that's got 2 traits, 2 custom traits. So this is representing FPGAs of 2 different classes. So how does this map to Ironic? In Ironic, we have a resource class and a list of traits for each node. And we can see that here in the output from this API call. So to request a trait from a flavor, similarly to the requesting custom resource classes, we request the custom RAID 0 trait and set that to be required. So we're saying this flavor requires any scheduled resource providers to have this trait. And Ironic knows which traits were requested because these get assigned to a field called instance info. So the node has both the list of traits that are supported, and when it's deployed, it has a list of traits that were actually requested. So to summarize, we have resource classes. Nodes are assigned a custom resource class, 1 unit thereof, and the flavor requests that resource class. You can also assign traits, and a node can have 0 or more, and a flavor can request a subset of a node's traits. So if a flavor requests a trait that a node doesn't have, then the node is not suitable for scheduling. Traits can also be assigned to the image, and those get ORed with the set of traits on the flavor. So we'll move on to deployment steps, the first of the Ironic features that we're covering here. It was added in Rocky, thanks to Ruby for adding that. It's based on the clean step model, so it should be familiar to anyone who's used cleaning before. And we define the set of steps that we want to execute during deployment, much as we define in cleaning the set of steps that we want to execute during cleaning. So the step should be familiar. It has an interface, a step, an argument, a set of arguments, and a priority. Going back to our state machine, these steps are applied during the deploying state. In the Rocky release, we have 1 mega step. And essentially what we did was take the entire existing deployment process and put it in 1 big step. So all you can do is to add steps before or after this mega step. We'd like to split that mega step into multiple core steps that you can then place other steps in between. There are some limitations to this feature at the moment, because for a given set of driver interfaces, i.e. for a given node, the steps are static. There's no way to influence at deploy time which steps are executed. You currently can't execute any steps on the deployment agent, the IPA RAM disk, and the use of a single megastep limits the ordering, so you can only add things before or after. So deployment templates, the main topic of this presentation, were added in the Stein release. We've added an API to register deployment templates with Ironic. And a deployment template is something that has a name, which must be a valid trait, and a list of deployment steps. So here's an example of creating a deployment template. We've got a name, which is a custom trait called custom hyperthreading on, and a list of steps. In this case, just a single step, which is using the BIOS interface step apply configuration to set the logical proc setting to enabled. And we've given it a priority of 150, which means that it runs before the mega step, which has a priority of 100. So how does this work end to end? The operator would create deploy templates via an Ironic API. And those deploy templates execute deploy steps for the allowed actions that the operator has sanctioned. The operator then creates Nova flavors or glance images with the traits that reference those deploy templates. And the user can create a bare metal instance using any flavors that are allowed to them, that are available to them. To try and put this into pictures, our operator first creates deploy templates with Ironic, and then flavors that reference those deploy templates by their name. And then later on, when a user creates an instance, it selects the flavor that that represents the deploy templates that they want to use. So we now have an API we can use to influence deployments. It's available through Nova. We don't need to go directly to Ironic. Some documentation here on how to use it. So hopefully by now our instance is deployed. Still going. Okay, so I guess we'll move on to hopefully this will deploy by the end of the demo. But
you check the state, is that right?
It's probably still going. Maybe I'm just talking too quickly. So I'll just carry on with some of the other commands that we can show. So let's take a look at the server. The main thing here to note really is that we're using this RAID 10 flavor that we saw earlier. So let's take a look at that RAID 10 flavor. So the main thing we're interested in here really are these properties. So we have our custom resource class that's assigned to the node, custom RC1, and we're requesting 1 unit of that. And we've set the memory and vCPU resource classes to 0 because we don't want any of those. And we've requested 1 trait, custom RAID 10. So let's take a look at one of our deployed templates. We can see it's got the name custom RAID 10, which is the same as the trait that we saw earlier, that we have in our flavor. And let's take a look at the steps. So our list of steps contains just a single step. We're using the RAID interface. We've got a priority of 150 to make sure that it runs before the core deploy step. And we're using the apply configuration in step on the RAID interface. And we're passing these arguments here. So the main argument we're interested in is the RAID config, which has a list of logical RAID volumes, of which there is one. It contains a list of the physical disks. We're not going to care about the size of the disk. We're going to name the RAID controller, and we're saying that we want RAID 10. Just to show the other flavor of the instance that we had previously that had 2 RAID 1 disks. It's very similar. We're using the same resource class, which means that it can be scheduled to the same node. But this time we're using a different trait, custom 2x RAID 1. So let's take a look at the deploy template. So we can see we've got a bunch of steps, and let's have a look at those steps in more detail. So it looks quite similar to the previous one, but this time we've got 2 logical disks, each with 2 disks in, and both have a RAID level of 1. So we're just picking out one of the fields of the ironic node that we're deploying here, called target RAID config. And we can see that our deploy step has set the target RAID config as we expect, so RAID 10 with 4 disks. Okay, go through the SSH dance again. And we're in. Okay, good. So we can see that this time we've got a single disk of size 744. And if you remember last time, we had 2 disks of half that size. Okay, so again, I missed my demo slide, but never mind. So let's talk about how we might expect RAID to look in the train release. As you may have noticed, we have some patches in our ironic service. We don't have a deploy step for RAID in the Stein release that would have allowed us to do that demo. So I patched the service, and that added support for to the DRAC interface in Ironic to do a RAID deploy step. One of the changes from the cleaning step here is that we don't have a separate API call to set that the RAID config. We're doing it all through the step. There are also some patches to avoid unnecessary reboots. So initially, when I first ran this, I think it took over half an hour. And it was doing 3 reboots, so a bit of optimization there to do it all in a single reboot. And hopefully, we should have this in the train release. So I think some of this will become more clear after the PTG once we discuss the things that people want to do. But I think we definitely want to split out the core mega step. And I think people definitely are interested in running deploy steps in the agent. So another piece of work that's going on at the moment is software RAID, and that does depend on having deploy steps executed in the agent during the deployment. So I expect that will be done during the train cycle. We need more deploy step implementations. So they do tend to be driver specific, so adding the DRAC driver won't necessarily add support for any other hardware. So we do need vendors and interested parties to help us implement those. Hopefully we can reuse the same patterns and reuse existing code from cleaning and the RAID and BIOS support that exists. We backed out of allowing execution of a step multiple times just because there are a few corner cases in there that can be a bit tricky, but it might be nice to be able to do that, i.e. to have separate deploy templates that add different BIOS settings and be able to say, I want all of these. People have expressed the wish to have something akin to manual cleaning, but for deployment, so saying, I want to execute these specific set of deploy steps, and don't go off and gather the deploy steps that are activated through through traits and the Nova scheduling system, but I want to execute exactly these. And the use case there is really for standalone ironic, when Nova isn't in use. We've had interest in executing deploy steps on active nodes. I think the main one that comes up there is BIOS tweaks, so being able to change a specific value after a node's been deployed, but without redeploying it. We'd like to remove as many unnecessary reboots as possible. I think if we go with the approach I've used, then we should be just at 1, which is probably the minimum. And I think we're not quite at the stage where we have vendor agnostic templates. So it would be nice to have a pool of hardware with different nodes from different vendors, and to be able to say, I just want RAID 10, and to be able to make that work magically. Whereas if you were looking closely at the deploy templates we had, then there were some Dell specific configuration in there. So I think that's really that's something that needs to change in the RAID support in Ironic itself to make it a bit more generic. That's all I have to say today. Does anyone have any questions? Jacob?
Can this functionality be used to tweak HCA settings or NP settings?
So the question was, can this be used to tweak HCA settings or NIC settings? I don't see why not. I think that's something you would do in-band, so we'd need to add support for in-band deployment steps on the agent, unless your NIC has some remote access that can be used. But
In-band sounds better. I don't think many platforms can do all of that. But is that something that's done today, or would it be extra implementation work?
I think that's something, it wouldn't work today. It would be an interesting thing to have upstream. Not quite sure where it fits into Ironic at the moment, but certainly be interested to talk about.
You would be active without redeploy. That's how I was thinking about like PTXP settings and then NIC settings as well. But you'd want to have that, not having to redeploy just to change that setting. I would say it's a prerequisite.
Yep, that would be good.
Is it possible to feed this with a shell script? For example, can I just specify, okay, can you download this onto the IPA and run it? Or is it limited to iDrive?
So the concept is not limited to iDRACs, but the implementation needs to exist for your platform. So All right. Any others?
So those specific settings that you've got for that, your del last for 30s, how did you glean those specific values? Is there a listing somewhere, or is it easy to gather that information?
There is some documentation in the Ironic online documentation about RAID, and I think the DRAC system is covered to some extent. I'm not sure how well it's covered. There's definitely some poking around that I was doing that I probably needed a bit more quite low-level understanding and directly accessing the iDRAC using the DRAC client. But hopefully that's something we can address through the documentation. Perhaps I'm doing it a disservice. Maybe it's amazing already. No more? Okay, thanks everyone.